Welcome to Hakam Inspire. Today, our guest is Mujeeb Ijaz, who is the founder and CEO of ONE, Our Next Energy. And many would have seen him and his company's achievement in the news earlier this year with them taking the Tesla Model S to 752 miles with ONE's Gemini battery pack. And we're going to be talking about that in depth in this podcast. Just as a background, Mujeeb Ijaz is a battery systems engineer with over 30 years of experience in the development of electric vehicles. So he's all about EVs and battery systems technologies. He led teams at Ford, where he developed, interestingly, the world's first zero-emission plug-in hybrid powertrain. And for this work, he was recognized by the United States Department of Energy. He was Chief Technology Officer of A123, where he and his team led the development of lithium-ion battery solutions for electric vehicles. In 2020, after leading energy storage as a senior director at Apple, he found Our Next Energy, which is ONE, where he is developing novel energy storage solutions. Mujeeb holds 38 US patents in the field of battery technology and energy management systems, and he is a graduate of Virginia Tech. Mujeeb Ijaz, welcome to the podcast, and it's great to have you on.
It's fantastic to be with you. Assalamu alaikum, and it's really good to be here with you.
Thank you. Lots of people are excited about the doubling of range which your company achieved with your battery pack in the Tesla Model S. And it's given huge hope to people, especially with the EV range anxiety. Lots of people saw it in the news, and we're going to be talking about that. But it'll be great to know your background, growing up as a child. How did you end up in this area and really focusing on alternative and renewable energy?
Well, I appreciate the question. I think if I look back at my beginnings when I entered Virginia Tech as an undergraduate, I didn't have a clear vision or sense of what I wanted to do professionally. And in my third year at Virginia Tech, I came across an announcement by General Motors that they were holding a seminar around creating a solar-powered vehicle, and they were looking for engineers to volunteer for attending this seminar. And as my mother was working at Virginia Tech as a professor in solar research and manufacturing solar cells, and my father also was a professor at Virginia Tech in physics, working on nuclear physics, I thought to myself that this could be an interesting intersection between my personal hobby of working on my own cars and working on something like a renewable energy or sustainable energy vehicle. And so I attended this seminar, and lo and behold, General Motors founded that, GM Sunrace USA, which invited about 30 colleges around the country to design, build, and enter a solar-powered vehicle for a race from Florida to Michigan. And as a result of that, it really did kickstart my interest in electric vehicle and battery development right from the beginning.
Wow, that's incredibly interesting. Let's get into the kind of the exciting project which some of us have seen on YouTube. And if anybody's watching the podcast on YouTube, we can always put a link to the description below. This project involving the Gemini battery, where you've kind of modified the Tesla Model S, and it's extremely inspiring and exciting, actually, just to see kind of the range which it achieved. So you achieved a range of 752 miles, whereas the normal Tesla Model S can achieve a range of 405 miles. Tell us a bit about the project, and also kind of the background, and a little bit about the Gemini battery itself.
Yes. So when we founded the company in 2020, one of the sort of clear areas that I wanted the team to focus on is the assessment of how high does the energy density of an electric vehicle battery need to go to where we can acquire the full market, meaning that all of the buyers of modern day cars and trucks would find the range acceptable in real world driving conditions, not in ideal conditions where you think of it as like a metro highway rating, but in driving the vehicle in winter at highway speeds, in mountainous terrain, and even under duress and conditions like towing, that we wanted to figure out what does that battery need to look like, that the future of electric vehicles could be that every car could become your electric vehicle and that you're not just selecting it as a third vehicle. And as I believe that sustainability and the future of electric vehicle requires robust solutions for batteries that achieve range that the whole market would appreciate, we worked on doubling the range of an EV as a signal that we were far away from solutions that in today's market would acquire the full market, that we would get eventually limited by the range of the vehicles not being enough. And so that became the mission of the company. So we endeavored in over a period of around 18 months, we were able to assemble the first proof of concept, a battery technology that we call Gemini, that would then power that vehicle the 752 miles. In part, we wanted to demonstrate that it was possible and work towards a future that as vehicle and battery OEMs work together, that the targets should be lifted, that today's status quo is not sufficient to overcome the real world range obstacles. And to give you an example, a vehicle that claims 300 miles, if you drive in the wintertime at highway speeds between cities, you might only achieve 150 miles. And that's the point of our exercise, is not necessarily that we're trying to say that 750 miles is the right target for a vehicle in everyday use. We're saying that that's the kind of energy you need on board to overcome real world conditions to achieve a very average trip of like a 6 hour from city to city. And once we can attempt and deliver that the full market would be then interested in adopting electric vehicles, cars, trucks, SUVs, the whole lineup of vehicles that are out there. And so we're working towards that goal.
So let's keep this. You touched upon the sustainability aspect. How are you working to achieve that within your project? Because I know traditionally batteries use nickel and cobalt. You've kind of turned towards other materials. And I know that very much at the core, kind of one of the core principles of Our Next Energy is kind of the sustainability aspect, the longevity, and reducing the carbon footprint. So tell us a bit about that and how you're integrating that into your company.
Yes, exactly. And if you think about now the early adopters of electric vehicles and the small quantities of vehicles that are on the road today compared to the entire market, electric vehicles globally, if you take the aggregate of global population, are still in the less than 5%, and in many countries, less than 1% of adoption. And at less than 1%, we're just at the very beginning. However, we've already taxed the supply chain for raw materials like cobalt and battery grade materials like battery nickel. And as nickel and cobalt are related to the foundation of new battery technologies today, we thought that instead of adopting that and then trying to make a better battery and a higher range battery blindly, we should actually look at the supply chain, look at the raw materials, study the carbon footprint. And as we studied the carbon footprint of battery materials and also the availability, being able to mine the materials anywhere in the world, irrespective of the geographic region, we came up with, through a Department of Energy report in the US, that lithium iron phosphate or iron-based batteries and then manganese or manganese spinel batteries would be two battery technologies and cathodes that would be significantly better for reducing CO2 and more abundant and available globally. And so as manganese and iron are materials that are vastly more abundant and lower cost, we decided to select those materials and then come up with a battery architecture that could work within those materials to then progress and create the range goals that we wanted. And that was not exactly a simple solution. If you think about the two materials I mentioned. They had previously been passed over a decade ago as not suitable for electric vehicles because they didn't have enough range. However, they had better safety, better sustainability, better CO2 footprint. And so that became our task, is how could we architect a new system, a new cell? And in doing that, we worked our way through a new way to develop a battery for an electric vehicle, leveraging these new materials that would then fulfill the goals of doubling the range of an electric vehicle. And that's what our company's core technology now is all about.
I think also, it's kind of going off what you're saying. It enables everyone then to produce these batteries. It's not just, for example, with a combustion engine or the current modern day fuel sources. There's only a few countries, handful of countries who have that fuel source, right? It's not everyone.
Yes. It's the idea of the haves and have-nots. When
Right.
you have a material and everyone else doesn't, then people generally will work their way and fight for their right to have that material that everyone needs, and that creates an imbalance in supply and demand. Today, if I look in 2022 versus when the company was founded in 2020, the price of nickel and cobalt have risen substantially higher than previous times, to where batteries that were costing $15,000 are now $25,000. And that is a significant problem in the commercialization of electric vehicles, that you select a material that becomes like the countries that have and then the many that need it and are working to fight for their right to buy it, and the price escalates. I think that oil is a great example of that, have created imbalance in the world, as well as a significant struggle for being able to sort of harness that asset. My goal and our goal in the company is to work on battery technologies that are not materially constrained and that allow manufacturing to take root in North America, South America, Africa, Asia, Western Europe, that as we are now deploying technology, it is not difficult to scale it no matter where you are.
Right. And so this will enable, of course, I can imagine that electric vehicles being available to the general population, more so in terms of cost, especially, but also practicality. And before coming onto this podcast, I was asking a few guys who have electric vehicles, and a huge aspect which I was kind of gathered from them is the practicality, which number one, and nice coming to onto the batteries, was the charging time. So they would say that, you have to have a charge at your home if you want to be the most practical, but that also means that you have to charge all night if you want to go, for example, 80 miles the next day. Or if you're going to a Tesla supercharger, it will be an hour and a half, but maybe there's someone in the queue there for you. So before you said, there's all these impracticalities which people are worried about. And it's, especially here in the UK, it's more of a luxury rather than your first vehicle, like you were saying. You don't want people having the electric vehicle as their third vehicle rather than their first vehicle. So in terms of battery and charging time, do you see in the near future, at least, or the distant future, where charging times can be reduced to 10, 15, maybe 20 minutes, similar to going to the petrol pump and spending 15 minutes there?
Yeah. I think that the charging time and like the need for fast charging should also be thought through with respect to two things you've already mentioned, which is that people need to find the station, but then they also need a station powerful enough that if 100 people want to charge that fast, that all of them get the power from the station, which is not easy. And the grid actually has some constraints on supplying that rate of power to so many vehicles simultaneously. If you pull into a supercharging station, I drive a Tesla Model Y normally, and if I pull into a supercharger and 20 other owners are standing at the station charging, I can be sure that the power to the entire node is divided by 20, I won't get the advertised charging time, even if it was possible to charge fast. There's still limitations on the grid side. Maybe like 8 months ago, I was invited to an inauguration event in Chicago for one of the mosques. And as I went to that event, I was making a decision when I left home. Do I want to drive my combustion vehicle that I have in the parking lot or the garage, or do I want to take my electric car? And I prefer to drive my electric car. So I drove the electric car. It's a 287-mile trip. And as I got on the road and I'm thinking about that, and I know a lot about, sort of the fuel economy at highway speeds for an electric vehicle, I realized I was going to not make it. Even though my range said 302 miles when I left, I knew I was going to need to stop. Well, lo and behold, when I got 150 miles down the road, I had to stop. And then when I got to Chicago, I barely got there, and I had to charge before I came back, which caused me to delay my return. And then because I can't charge fully, I had to stop twice on the way back, not once. And so I ended up stopping to charge 4 times, which was a very good lesson in the inconvenience if electric vehicles are not fitted with enough range to begin with. And that's where I think the secret lies to the adoption. Is just like our cell phones. We are all commonly aware that a cell phone that can get you from morning till you go to bed without bothering you to need to charge is better and more convenient because it doesn't stop you from usability. Similarly, an electric vehicle that can go from point A to point B on a distance trip, like a 6-hour or 5-hour commonly done road trip, it's very useful to avoid needing to interrupt that type of trip. And so we analyzed that problem in trucks, SUVs, sedans. We analyzed it at different speeds. And we took into account the future that electric vehicles need to deal with all markets. And one of the best markets in the world is Norway, where their sustainability goals have been like much longer standing. The adoption rates are much higher. But I've spoken to people that own electric vehicles in Norway, and they have a very difficult time because of the temperature and losing range in the wintertime because of just the temperature of the battery, and also driving long distances that don't have charging stations available. So I think that we're trying to now overcome that level of need for a 10-minute charge by actually fitting enough range to right from the very beginning.
So just on that, obviously if you achieve a battery which has a higher range or a higher density or battery capacity, you're in theory adding weight. And how do you overcome that? So are you able to kind of match the current weight, and does that affect performance of the vehicle itself?
Yeah, our goal is to actually match the weight, match the size, and double the energy. That is our goal. If we can match the weight and size or physical properties of the battery altogether and double the amount of energy on board, then I believe we have achieved the intended goal of not placing additional burden on the vehicle. Because, by the way, as a electric vehicle engineer for many years, the batteries have become, practically speaking, as big and as heavy as is possibly allowed. And that vehicles are already bending over backwards, so to speak, and accommodating this big, huge battery. And for anyone to think that we could just double the weight of a battery, that also is not practical. So we looked for a solution that could double the energy density, both volumetric and gravimetric, so that we are not in a situation to additionally burden the vehicle. And that's how we set the targets for our battery system, is that we wanted twice the volume density and twice the weight density of today's commonly used EV battery.
And how about cost? Because then is your battery also going to be cost effective comparing to other?
Yeah, cost effective means matching the same dollars per kilowatt hour, yes. But we did not yet achieve a goal of making it half the dollar per kilowatt hour, meaning if we put twice the amount of energy on board, it costs the same amount as today. We did not achieve that. But let me explain a little bit around that. And as we've talked with automotive companies, we see an opportunity here that in the future of vehicle deployment, I see three differences in electric vehicle that don't currently have a parallel in a gasoline vehicle. The first is that the premium option for an electric vehicle is not going to be horsepower or leather interior. The premium option is going to be range. It's going to be related to range. And you'll sell an electric car with a base range, and then with a medium range, and then with a high range. Well, part of what we've done in our architecture is made it possible to have a battery that has a base range, a medium range, and a high range all in the same size package. And that gives you the option to upsell energy as one of your premium features. And today, Tesla charges $10,000 of retail price for every 100 miles of extra range when they offer more than one battery option. So we think there's a real option for automotive companies to charge for range. And so we believe that that's one way that they'll adapt to the cost structure of the battery that we're offering. The second attribute that is kind of interesting in the purchase of an electric vehicle is that when you come to the price of the vehicle, a lot of times people think not about price, but around payment. And electric vehicles are lasting longer than gasoline vehicles by far. It's not uncommon for an electric vehicle to have a better resale value, and even thinking about how durable. Right now, 500,000 miles is not out of the question for the durability of an electric vehicle. And it's a bit more like an appliance or an electronic machine than it is a piston, which has got mechanical wear out, or a transmission with mechanical wear out. The electric vehicle is going to last longer. Therefore, I think as time goes on, banking and payment structure for electric vehicles will start gliding further down the road, maybe to 10 years. And as you do a 10-year against the value of the vehicle, and you then do a loan package, people will start affording electric vehicles differently. And that's always tied to residual value or resale value. And so for those reasons, I think there are some differences that are coming. My last word on this is that electric vehicles that can double the range are going to be resale value much more valuable, because you can use them for much longer, because it's not like the electric vehicle wears out and the range is not useful, because your daily need for range is 150 miles. And if the battery's capability is 750 miles, even 10 years later, if the battery were capable of 600 miles, that's still a very good vehicle, not one to be discarded. And so for those three reasons, I see an opportunity here that would help us in residual value, in the loan package, or how long the loan would be, and how much people pay for range or electric vehicle distance.
I mean, do you think that this technology will create a disruption in the market where we do see in the near future that people head more towards electric vehicles? You've talked about how it may be different options on how affordability can be achieved. And I suppose, is there a market for hybrid vehicles, or is that something that's sort of as a bridging gap between the time that we take to achieve this kind of wholesale EV market?
Yeah. So on the issue of market, I think that where my mind goes immediately is that people want the products they currently like, and not necessarily the products that are only being offered. And if you look at electric vehicles right now, a vast array of them are sedans and very highly efficient, aerodynamically efficient, like aluminum-bodied sedans. Not very often are you finding the electric vehicle truck or the large SUV or the minivan. And there's a reason for that, because the inefficiency at highway speeds is exacerbated. It's much worse. It's much harder to overcome the negatives at driving at high speed on the highway. With the fuel efficiency implications, the range of the vehicle drops so quickly that it would basically astonish the market that they lose half their range by going on a trip. What we're thinking here is that our battery will enable a new type of vehicle that really does service what the market wants, which are trucks and SUVs and minivans. That segment of the market is around 70% of the US market has gravitated towards those vehicles, but a vast majority of electric vehicle offering is actually in a different class of vehicle because that's where the equation is best solved right now. So we're not necessarily thinking that you put 750 miles on a sedan and magically the market is much better, but we think that we will enable the truck, the SUV, the minivan that doesn't exist in the right way to then the market will gravitate. And that's how we think we can accelerate adoption, is actually flood into the bigger market with products that people want that are not going to disappoint them. Your question about hybrid, my thinking about hybrid in terms of gasoline paired with battery is that small battery, large engine has been tried, plug-in hybrids, 40 miles range for the battery, and then the engine comes on. I don't think the market responded very successfully to that model because actually the 40 miles that could fit was not really close enough to what people wanted. And people that buy electric cars want the full utility of it being electric. I think if we can get past the range numbers that allow a successful adoption that an electric car could be your only car, we're not needing to deal with a hybrid anymore using an engine. I think the engine will then slowly and surely march down the ladder, and electric vehicle batteries will march up the ladder of market adoption.
You were talking about how you have these changes in not just what the current market is, but you want to move away through this massive gap in the market. I want to ask, do you think in the future we'll be able to go into our main transport systems like trains, aeroplanes included, to alternative energy, if that's electricity or something else?
Oh, I definitely think that.
Okay.
I think that the market starts out, as I mentioned, with the easiest and lowest complexity of adoption, and it works its way up. So you start out with, let's say, passenger cars. I come along with an idea that let's get into light-duty trucks with batteries that are doubling the energy density. And then you get to tripling the energy density, and you'll enable potentially marine applications. Think of it as like pleasure craft. Then you quadruple and you'll get into the 18-wheelers and heavy-duty trucking, and maybe you quintuple, and all of a sudden you're in vertical takeoff is in a great place and can operate successfully and manage trips and so forth. The reason that I think that persistent march will happen is something that my mother and father taught me when I was growing up, which is that fossil fuel is made one way. It's made with time and Mother Earth. That's it. You have to have a lot of time, and then you have to have Earth's natural processes to boil the carbon-based materials down into natural gas and oil, and those fossil fuels and coal. And those fossil fuels are not renewable and not abundantly replenishable. We just have to keep finding more of them and depleting them. What is very fascinating about electricity is that you can make electricity 10 different ways. You can make it with solar, wind, hydro, nuclear, geothermal, coal-based, natural gas-based, et cetera, et cetera. You can go all the way down the channel of making electricity in so many different ways. And the second thing that I found really interesting as a thought experiment is my dad was telling me one day at the dinner table about shipping oil in a tanker and how much energy that takes versus how light an electron is and how fast it can travel across the world or across the country. In shipping your energy, you can produce it anywhere and you can deliver it right to your doorstep in a product that is packaged in the electron. And the electron's mass being low, speed being very high, it's very easy to imagine a future when you have 10 different sources of electricity and your shipping of that electricity can be distributed on an electric grid, that is a successful vision for how the future of energy and energy storage should work together to enable many, many different products. And so I'm convinced that energy storage is going to accelerate, that we're going to create higher energy density, and that we can bring new battery technologies, constantly improving the state of energy density to help enable new products.
So just on that, do you think of the sort of talking about the wider applications? Do you think there's a scope for energy to be supplied to less economically developed countries to help kind of improvement and development in those areas? Do you have any comments about that?
Yeah, not only do I think that there's hope for that, I named the company Our Next Energy, and the hour in Our Next Energy refers to the total planet and the 7.9 billion people now that are on it. I think that my goal in energy storage, if I were to put a little baseline idea before I answer the question, that oil was discovered in the 1900s, early 1900s, and even before that in Saudi Arabia in vast quantities, but it wasn't valuable until the oil tanker. It wasn't until you could move it around and store it that it became a deployable idea. An electron tanker is the equivalent of a battery. Now, as a battery has a small bucket, it's inconvenient to have so many and to need them everywhere. But the bigger and bigger the bucket, or the more you can store, the more successful the transition will be to electricity. I think the developing world will leapfrog the first world in energy storage technologies, as well as the adoption of electricity and electric vehicle products, much in the same way that landlines not being completed in the third world caused cell phones to rapidly, almost like as rapid a progress as you could possibly make in Pakistan and India and many developing countries. Cell phones became massively successful in much shorter time than even in the developed world. I think the same thing is possible. And one of our goals at ONE is to make that future possible by deploying sustainability ideas around batteries, how batteries go into products, how the grid and the utility value those products, and how you can deploy renewable energy around that. And we are actually in an active project working on a third world-based idea, technology that can help deploy more rapidly an integrated energy storage and energy generation device that would then help facilitate that transition.
It also that's amazing, because if that will be possible, God willing, that will just open up so many avenues for these people in the third world who maybe their countries can't afford getting so much oil. But not just that, day-to-day living is maybe expensive for them, but their wages are very low as well. So it will open up this, unlimited resource for them. And it's just going to be wonderful for their quality of life.
Yeah. There's a very fascinating book written by Bill Gates, and Avoiding a Climate Disaster, I believe, is the name of the book. And in that book, there's a reference to a chart that he helped create, which is to study the correlation between access to energy or electricity and the gross domestic product or output of a country. And if you look at it, they're actually very correlated, that countries grow according to the onboarding of new energy sources and ideas and giving people access to energy. And it makes sense because the democratization of energy is at the root of education, industrialization, machinery that can help create productivity, communication, which again goes back to electricity being education in a nutshell, electricity will also, in my way of thinking, enable clean water by capturing humidity from air. When you lose access to clean groundwater, electricity will be another avenue to the lifeline needed, which is clean water. And so as I think about this, deploying electricity or creating energy storage and electricity generation pair in the third world is the necessary ingredient to raise their economic status and position in the world. And it's possible. It's possible because it is not about a fossil fuel that's the haves and have-nots. Everyone has access to renewable energy because solar, wind, and all of the other technology sources that we talked about, and hydro, especially hydro, are available around the world. So I think that as we dream about what's possible in the future, I think it's very plausible that this generation of battery storage is coupled with generation, and it will enable the developing world to get access to the needed energy to grow their economies.
It's incredibly inspiring, having this discussion with you, just talking about what's possible in the future, and very realistic as well. I just want to touch upon your personal motivation. What inspires you and has motivated you towards this field and sort of thinking of the world as a whole, not just kind of marketing your own battery, but you're thinking of sustainability, you're thinking of wider applications of energy and renewable energies. So what's been your personal motivation for this?
Good question. I think, first of all, I think of my belief system that we're given a task here on Earth and a duty. It's like you can kind of commingle your faith, which is I was created by a creator. What's my purpose? And ever since that, college project working on a solar car, I feel like I found a rooted purpose, which is advancing sustainability and energy storage. And so I do that as maybe you could say a personal belief that that's my purpose on Earth. But then I couple that with a distinct idea in Islamic teaching, which is that service to mankind is correlated with your worship of God, that you should find a way to serve mankind in as many significant and insignificant, meaning small and large ways as you can, to then couple with your belief system that that's how you show worship and appreciation to your creator. And in my view, creating sustainability and energy storage technologies that can get deployed to the world of people that don't have access is a core value of mine. Again, the name of the company, Our Next Energy, is I kind of want that global hour to eventually be where this company goes. Now, of course, today we're talking about powering an electric vehicle that costs $100,000, 750 miles. That doesn't sound like a third world product. It doesn't sound like that's giving access to the masses. But in one of my visits to our global spiritual leader, Khalifatul Masih Hamas, who lives in London, he specifically told me to work on technology for the masses. And as I think about how to do that, I think it's about bringing about the type of technologies choices that a developing world could adopt that would give people access. Just the last discussion that we had, that's what's motivating me. That's my end goal. That's where I want to see our company go towards. And I do see a way to do it. I think that people in governments that are struggling with deploying utility scale energy around a country, they're faced with billions of dollars of investment required to do it in a traditional way. Our idea is that we probably could do this in a much more micro generation, where you distribute generation and storage in product ideas that still aggregate to the same cost, but you're now distributing it across your people and giving them access in a unique and different way. You basically create productizing energy generation and storage instead of utility scale within landlines. And just like a cell phone is a device in your hand that has everything, I see that we can do the same thing in generation and storage. And so that's kind of what's fueling my motivation to continue working here. Is there are around 2 billion people on Earth that don't have access to the fundamental human right of access to energy, which is education and everything that we talked about.
That's really inspiring. And you referred to your Muslim faith and Islamic teachings. For the youth out there who are listening right now, and they're aspiring to innovate, to create change, to serve mankind, like you're saying, what kind of advice would you give them, and how would you motivate them to definitely pursue this line of innovating, exploring other ways through which we can benefit mankind? Because in the Muslim world, we know historically there's been huge amounts of great thinkers, scientists who created many things which propelled science forward, which Western science actually is based on. So, how would you kind of inspire and motivate these youth who are growing up?
I'll give you a story about starting our company. When I left my job at Apple, July of 2020, thinking about what I wanted to work on, I had the idea that we should go after doubling the range of electric vehicles, but I didn't know how. And as I wrote that goal down, 3 months went by, roughly October that 2020 year, and I started feeling like, man, this was maybe not a great idea because, I left my job and started this company, and I was I was the only person in the company, and got this really lofty idea, but I don't have any idea of how to do it.
So you didn't,
And
just to kind of come in there, you didn't, after you left Apple and created One, you didn't have a plan, or you didn't know how to double this range, but you had that goal.
I did not exactly. And I can say to you that it comes from the place of, if you want to disrupt, if you want to create a disruption, you have to set your sights on the change that is needed, and you have to be bold enough to be willing to work on something that doesn't look possible. That's the key ingredient, is be willing to work on the change that you're trying to create. And in the third month of the company, one morning I woke up with a completely different view of how a battery should go together. And I thought, that's actually a good idea. And I realized that in that inspiring moment, to me, I should first of all thank my creator. I should say that it wasn't born out of my intelligence. It was granted to me because of my belief system. And I think that, it's hard. Certainly, if you're in the professional world, you'd say that's not a very good business plan.
Yeah.
Because it doesn't look like you're going to be very successful. But I think that in some ways you have to endeavor to want to create a change before you can be a part of creating that change. It's like your intentions are first made, and then after those intentions are made, you're struggling. You go through a struggle. The struggle is the search for, how can I solve a problem that hasn't been solved before? And as I would say, I'm giving advice to the people listening, especially, I hope, younger minds that are very eager to think about how to create change, is don't be afraid of imagining the future in any field. It doesn't have to be in engineering. It could be in science, medicine. It could be in civil engineering, mechanical engineering, whatever your fields are. You go after the problem you think is worth solving, and then you seek enlightenment and guidance through prayer and perseverance. That's my message. I was asked by a reporter to describe myself in 5 words, which at the time I was like, that's going to be really hard and I can't think of 5 words. And then it came to me that disruption requires creativity and persistence. You've got to find new ways, because that's your creativity is really the process of discovery, but persistence is not giving up. Persistence is if you let down yourself with, I tried, but I failed, then you probably won't be very successful in finding that new solution. So you have to kind of push after it. And I don't think my company was really founded in 3 months. I think my company was founded in 32 years and 3 months, meaning it took a 32-year background of struggling with technology and trying to figure out the road for electric vehicles. But then it took a little bit of an incubation period to actually have an idea that would then be the foundation of the company's technology and how we are now building it today.
No, that's super inspiring, and it's interesting you say that, you know, one day you had this thought and you thought of how the batteries work in a completely different way, and you thanked the creator, because also the second caliph of the Ahmadi Muslim community, he wrote and spoke about this issue at length, and he said that when scientists make great inventions or discovery, actually that's a kind of inspiration which they're getting from God, and it is actually from God, and then you see those revolutionary changes. So it's been super inspiring, really interesting, and we really hope the listeners as well enjoyed the podcast, and we can't wait to have you on in the future, and honestly, all the best for all the great work you're doing.
Thank you very much. It was good to meet both of you today, and good luck with your program. It was actually, your questions were inspiring to me. You brought out for me a lot of ideas that also enriched my day. So I appreciate your questions.
Thank you very much. Thank you for listening to the Al Hakam Inspire podcast. We hope you enjoyed it. Visit our socials on Instagram, Twitter, and YouTube at Al Hakam Inspire. And of course, subscribe to our YouTube channel and leave your comments there. We would love to hear your feedback and thoughts, so send us an email to inspire@alhakam.org.